Okay, so today we're going to learn about scatter plots and trend lines, or line of best fit is another way of saying it. So just some terms that we'll have up at the top of the page. So whenever we have a scatter plot, we can notice different trends. So the first trend is going to be when I have a positive correlation. And so in a positive correlation, as I'm moving from left to right, so as my x increases, my y is increasing as well. And a really good way of thinking about it is that it has a positive slope. So when I see, like in this first one, in this first graph, I see that I have a positive slope right here. So as I'm moving from left to right, my graph is going up, so that has a positive correlation. And what we'll actually get into here is we're going to get into having finding an R value. And so that just shows kind of how tight the correlation is, how clustered the ordered pairs are, and then also it'll tell us whether it's a positive or negative. So when we have an R value that's close to 1, that's going to be a positive correlation. The second one, again, same kind of thing. So a negative correlation, So negative correlation is going to be that when my x increases, so as I'm moving from left to right, my y decreases. Again, it has a negative slope. So as I'm moving from left to right, in this middle one, as I'm moving from left to right, my points are heading down. That's a negative slope. That's a negative correlation. And again, when I have something like this, my R value that will get calculated is going to be close to -1. And then the last one that I have is if there's no correlation, there's no real pattern. When you look at this last graph right here, I just have a bunch of points, and it's really hard to even get, there's no real pattern. It just kind of looks like everything's kind of spinning around. So when I have a no correlation, what ends up happening is I have an R value that's close to 0. When we go into talking about correlation, sometimes correlation and causation get mixed up. So causation is when a change in one thing causes a change in another. So when I look at this first example right here, where I have hours of study versus test scores, again, just by looking at it, if I'm following the general trend of this, that as I'm moving from left to right, this is going up, so this would be a positive correlation. That's the first thing I'm going to write underneath of it. And so when I draw my line of best fit, again, when I'm hand drawing, I'm kind of guessing a little bit, but kind of draw as straight of a line as you can get. I want this to be kind of as close as I can to all the points. It's really kind of a guess, but I do know it's going to be positive, and it's as close to all those ordered pairs as I can get. And then just thinking about it, hours of study versus test scores. If I study more, I get a better score grade. Though that could be causation, where as I study, I can get a better score. With this second one right here, car weight, again, the general trend that I have here is that as I am going from left to right, my ordered pairs go down. So as my car gets heavier, I get less miles per gallon. So when I draw this, it's kind of hard actually because they're a little more scattered, but something kind of like that is kind of split, is close to all those points. This again is a negative correlation. And again, this is another example that this is causation, because a car's weight is going to affect the miles per gallon because it's going to take more gas or more energy to move a heavier car. And then the last one here, again, I should be able to look at this and see that as I'm going from left to right, it is going down. It actually kind of looks like it's curved a little bit here. But we're going to do, just for the time being, we're doing all linear. So this one's kind of hard because something like that. I don't really like that. Something like that. And again, I can see this is going to be a negative correlation. And then again, this is the position of Google search results. And again, the position is going to affect the amount of people that click on it. So that would be another example of causation. So, yep, that kind of does that there. Negative correlation, positive correlation, and causation. If you flip over to the back, the way that we are going to do this is we're actually going to calculate a line of best fit. And instead of doing it the long, hard way by hand, we are going to use Desmos. And so the way that we're going to do this is I can make a table on Desmos. So I'm going to slide over to Desmos. And if I click in the top left-hand corner, click the plus button, I can actually make a table. And so what I'm going to do is I'm going to enter my ordered pairs here in a table. So it is -4, -2. -3, -3.5. -1, +1. Oh man, this is going to get old fast. There we go. 3, 2. 2, 3.5. And 6, 4.7. So those are each my ordered pairs. Just double checking to make sure that those are all right. That is good. And so again, when I'm looking at, I should be able to notice that this is, I can't do it over there. Just by looking at the points, I should be able to see that that's a positive correlation, okay? And then what I can do is I can actually use Desmos to automatically calculate my line of best fit. So in here, and so here, what I'm going to do is I want to type in that y1 that I have up here. Oh, can I copy it? If you guys can copy it, it's way easier to copy. I think if you highlight the y1 and press Control-C, that copies it, and you can paste it down here. But if you can't, you can always type it in as y. Then this little a sub b will get you into that subscript. There you go. Once I'm done with that, then I click to the right, or I can click the right arrow. And then I want to put this squiggle, which again is in my in this little ABC button that I have there on the keyboard. And then what I'm going to put is mx sub 1, and then plus b. If you are having trouble doing this, just grab me and I'll help you do it. Again, if you can copy and paste the y1 and the x1 and put them in there. But this is y equals mx plus b. M is my slope, b is my y-intercept. And so what I can actually do here is this calculates my line of best fit. And so when I do this, on your paper, you can write that my slope is 0.7, I'm going to round to 2 decimal places, so 0.76. And my y-intercept b is 0.57. And so, again, when I do this, what I'm actually going to do next is I can see on my graph over here on Desmos that red line is splitting those points. What I'm going to do is I'm going to go ahead and I'm going to draw it on my graph. So I'm going to plot the points. So I've got -4, -2, -3, -3.5, oops, put that in the wrong spot. And then -1, +1, 3, 2, 2, 3.5, and then 6, 4.7. 1, 2, 3, 4. Again, whenever you have decimals, you're kind of guessing a little bit. And then again, if I've got my, m is my slope, b is my y-intercept, again, I can write any equation just like this. And so I can plug in my slope, which is 0.76, and my y-intercept, which is 0.57. So when I draw, like if I wanted to hand draw my line of best fit that I've calculated here, this is my starting point, my y-intercept, where my graph crosses my y-axis. And then this is my slope. So I'm going to start about halfway up. And then for each line, I'm going to go up 0.75, which again, if I go up, right here would be going up by 1. Going up about there would be 0.75. Good. Something like that. So for each line, I'm going up by 0.75. And then I could go ahead and draw my line like this. And there's my line of best fit. Again, that's that same line that I had on Desmos, but I'm plotting my ordered pairs and I'm seeing that line of best fit on my paper. Okay? And the one thing that's kind of nice about doing it on Desmos is what I can do is when I go down to the next problem, I can just change my table and it'll auto-calculate. The other thing that I want to point out really quick is that, let's see, with this problem right here, I've got my R value, and we're actually going to use the R squared value, is 0.84. And again, if we look at the top of our notes, our R value, which is what that is, if it's positive correlation, it is close to 1. And so when I look at this, 0.8 is close to 1, so that gives us a strong positive correlation. The closer to 1, the stronger or the tighter the points are to that line of best fit. If it is weaker, it is farther away from 1. So that's a pretty strong positive correlation. Okay. And so, again, I'm going to go down to the bottom one there, and I'm going to go ahead and change those. Let's see. Oh, there we go. So it's -3, and then 5. This is -2. Oops, -3, 5. -2, 6. 0, 3. 3, -1. 4, -4. And 5, -3. And again, just by looking at the graph right now, I should be able to see that that's a negative correlation. It gives me my slope, it gives me my y-intercept, and it gives me my R value. So those are going to be the things that I write down. So M is my slope, which is -1.24. My B, which is my y-intercept, is 2.45. So again, when I write this out, my slope is -1.24, and that should make sense because it's a negative correlation. It has a negative slope, and then 2.45 is my y-intercept. And then my R squared, again, my R value right there, which is how tight my correlation is. The one I'm actually going to go with a regular R value is a 0.968. And again, that's really close to -1. And so that is going to tell me that I'm a strong negative correlation, so closer to 1. I guess for this top one, I should have used my R value rather than my R squared, which I believe was closer to 9. It was 9, I think it was 9.4 is what it was. Okay, and again, there's my R value. And then what I can do is I can do the same thing. I can go ahead and plot my ordered pairs on my graph. So -3, 5, -2, 6, 0, 3. Oops, I didn't like that. 3, -1, 4, 1, 2, 3, -4, 5, -3, something like that. When I'm drawing my line of best fit, again, I know that my y-intercept is 2.45, so 2.45 should be right around 2.5, which is right there. And then my slope is -1.24, so I'm going down 1 1/4 almost. So go down 1 1/4. Go down 1 1/4, 1 1/4, 1 1/4. So I should get a line of best fit that looks something like this. There you go. Again, there's my handmade line of best fit calculated by Desmos. And again, once I have this formula typed in Desmos, the y1 squiggle m x1 plus b, then I can just type in my tables and kind of go from there. But that's line of best fit and how to calculate it on Desmos.